Coming up this week on the Digital Lifestyle Show 938, we've got a fascinating show for you. Pete Brown from Microsoft joining us to talk about MIDI 2.0 and Windows. And he's also executive chairman of the MIDI Association. So he's going to be talking about what MIDI 2.0 is, what MIDI is, why you have it in Windows, all the new features we're going to get, and we get some live demos as well. So, Pete Brown, welcome to the Digital Lifestyle Show.
Thank you. Great to be here.
Yeah, it's really good to get you on the show because this is a real convergence of all my interests in one thing. If somehow we could fit it in with a Formula One car, that would be all my interests in one thing. Because we're talking Windows, we're talking Windows technology, we're talking MIDI, synthesizer, music technology, all converging into one show. So this is really exciting for me. So really do appreciate you coming on the show today.
Thank you.
Now, we're going to be talking MIDI 2.0. That's primarily why I wanted to get you on the show. So before we go that, just give us a bit of background on you and what you do at Microsoft.
Okay. So I do a lot of things at Microsoft. I run the Windows Developer MVP program for our developer MVPs, which, we have MVP Summit and stuff coming up next week, which will be super fun. And I'm on a team in what's called the Adept group, which is the developer platform folks. And my general focus, I do a lot of things, but my general focus these days has been on updating our MIDI stack in concert with the audio team to try to kind of bring it up to speed with all the changes for MIDI 2.0, as well as fix a lot of long-standing requests that we've had from musicians and customers over the years and try to make that generally better. I'm also the chair of the executive board of the MIDI Association, which is the standards body that manages the specifications and everything about MIDI and MIDI 2.0, and participate a lot there and some of the standards definitions and whatnot.
Right, yeah. So me and Gary know you from the Microsoft side, from the MVP side, which is great. Now, MIDI. Because where not everybody listening to the show understand what MIDI is. So just give us a background of where MIDI is and why it's such a long and all well used standard.
Yeah, MIDI is, well, it's old. It's probably older than at least half the people watching this podcast at this point, right? So MIDI 1.0 originally came out in 1983, and it was introduced at the NAMM show, where it was, and I'm going to mess this up, but I think it was a Roland Jupiter 6 and a sequential Prophet. I'm not sure which Prophet it was, but there was a sequential synthesizer that went with it as well, that showed the first time that there was a standard method of communication between two different manufacturers' synthesizers. Like before that, it was all, Roland had DCB and DIN sync, and like there are other standards from other manufacturers, but they couldn't talk with each other across different brands. And so this MIDI thing came about to enable you to take one synthesizer and play another, and it kind of led to, like the big thing in the 80s with synthesizers was, hey, let me stack this very percussive sound with a string pad behind it, and I can play them both at the same time, which we take as granted for granted now, but back then it was a big deal and something very new. And it also led into really kind of hip hop and a lot of beat production and all the things that relied on having like MIDI clocks and being able to synchronize between different devices and have performances around that. And so it was a technology that really enabled a lot of what we think of as just general electronic music today, right? And for people who aren't familiar with it, MIDI it's control signals. It's one MIDI device tells another MIDI device, play this note at this velocity, right? And then stop playing this note. Or, here's a clock signal, synchronized to this clock signal. I'm going to send it every, 96 times per second or whatever, right? So those are the types of signals that get sent across. It doesn't do audio. It's just those. The standard generally stayed the same for quite a long time. Like the first really big update to MIDI was the addition of USB MIDI in 1998, 1999, somewhere around there. There was this idea that, hey, maybe we really want computers to participate more and not just using these serial connections. We want to have, this new USB standard to be as part of that. And so that was one of the big updates. And then since then, MIDI 1.0 has added stuff like uh, MPE for being able to communicate, more expressiveness from different types of keyboards. It's added Bluetooth MIDI for being able to communicate with Bluetooth devices, and it's had a lot of other small updates since then. And then back in 2020, we released the MIDI Association released the first version of MIDI 2.0, which I know is something we're going to talk about a bunch here. But that was like the first major update and revamp of MIDI in 40 years, right? And then there was a second update to that in 2023, which is kind of what we're all working with today.
Yeah, so it's a remarkable standard. Now I've got a a 2024 synth or key controller over here, and I can plug it into my 1998 synth or my 1985 drum machine over there, and it'll still work.
Right.
It's amazing the longevity of the standard.
And it's not just that. It's we often talk about this in the MIDI Association because it is really a big deal, but it's one of the only places where you'll get like I'm on working groups with folks from Apple and Google and the Linux ALSA folks, as well as us. And we're all working on the standards together in a very cooperative environment. And you also have Roland and Korg and Kawai and Sequential and all the different DAW manufacturers, and everybody there all working together cooperatively to make this stuff work well. And that's, I don't want to say that's unusual, but it's kind of unusual to have that many competitors in the same place at the same time, all working towards a common goal.
Yeah, and there's not a competing standard either. We've not got Betamax versus VHS or HDVD, Blu-ray, that kind of thing.
Well, there are a couple, but like those tend to be more niche. There's I completely forget the name of it, but there was one standard that was trying to do what MIDI 2.0 has finally come out to do, but they were like well ahead of everybody and pointed out the need for that type of stuff. It just didn't get the type of widespread adoption because you do need to have that critical mass of operating system companies and software developers and hardware developers to all agree, like, yes, this is what we want to do going forward.
So we've got MIDI. It's all good standard. PCs controlling the keyboards, or keyboards controlling PCs. Everything works fine. Soft synths all controlling. So why do we need MIDI 2.0?
So if you think back to 1983, right, the processors that were available in synthesizers and stuff at the time were like they're barely even up to speed with microcontrollers you might have in a small device today, right? The heaviest processors you're talking about, like Z80 type things or 6502 MOS stuff like we might find on a Commodore 64. These were all great at the time, but they had limitations for how much they could do. And as a result, one of the things that happened with the original MIDI standard is it was locked at 31250 bits per second, right? So roughly 31K. And that is a somewhat limiting factor because musicians are always counting milliseconds of delay for every single thing they do. And at MIDI speed, sending a single note on message, the fastest that will go at 31250 is 1 millisecond, right? So to send one note on message takes 1 millisecond. If you hold down a chord of 5, there's going to be 5 milliseconds between the first and the last there, between when those can be processed. And that was just like a limitation of what was available at the time. The other thing that lower speed enabled folks to do is you could have ridiculously long DIN MIDI cables that were like 50 feet stretch across the whole stage. You didn't have to worry about that. As anybody who's tried to buy longer USB cables today knows, like the faster you go, the shorter the cable has to be because otherwise it just becomes a massive antenna and you get lots of interference. So there's the speed issue is one. Second is there have been lots of these little additions that have come to MIDI that like MPE is a big one, where the way MPE works is it tends to split each note, give each note or so like its own different channel that it uses to communicate. So in the 16 MIDI channels, you kind of use those all up for one performance, but it gets you that better polyphonic expression. Yeah. That was kind of a hack that fit into MIDI 1.0. And so there's this idea like, hey, why don't we design MIDI 2.0 from the ground up to be more supportive of these types of features that weren't envisioned when MIDI 1.0 came out. And at the same time, why don't we make sure that it's expandable? Why don't we make sure that there's room to add new types of messages? Why don't we make sure that we have like a standard packetization of messages so that we can send them back and forth easily, and it'll work on any transport, not just DIN plus whatever we managed to hack together for other stuff. And then there's the idea that devices today should have a bidirectional communication, right? So, you were talking about some of the like the Korg key stage that you had picked up. Wouldn't it be great when you change a value on the key stage that it sends a message back up to the computer, but the computer at the same time can send a message back saying like, hey, here's what actually changed when you did that. Or the key stage can say, hey, get me all the list of your patches that are available. And then the computer can come back and say, all right, here's all the patches I have available. Here's the different numbers for them. And you can have that communication. Or the key stage can say, or any of these devices can say, hey, I'm a piano. Do you support the piano profile? Right. And if so, come back and, I know to map these controllers in a certain way. And I know that I need to have these levels of expressiveness in the velocity. I know that we support these other things. And so like being able to have those types of communications, that bidirectional communication between different devices and devices in the computer is a really important part of why we had to update MIDI to MIDI 2.0.
Yeah, and having used that with the key stage, that's great. One of the nice things when you see the display suddenly comes on with, especially if you're using soft synths, using the Op6, and it's got the patch name on, and as you're scrolling through them, you don't have to go to the computer to do it, and the parameters are all there. You can adjust the filter cutoff or whatever. It just says them all there. That is just something that's so simple, but it makes so useful. Which I know you couldn't do before.
Right, and the interesting thing is we kind of break MIDI 2.0 up into a couple of different pieces, and they're somewhat confusingly just because of the history. Like I understand the history of why we named it this way, but it tends to be somewhat confusing once it starts showing up in marketing literature. There's this thing called MIDI CI, which is MIDI capability inquiry, which gives you that bidirectional communication, and that can actually run over MIDI 1.0 transports. So you don't have to have anything other than updated firmware or software for that. Like you don't need to have new types of communications methods, new drivers, or anything like that. That capability inquiry, the profiles and the property exchange that go with that can run over MIDI 1.0. And that's what the key stage is doing. So that's the MIDI CI part of MIDI 2.0. And then there's the UMP, Universal MIDI Packet, part of MIDI 2.0, which is all the rest. That's the being able to do exact pitch on a note on instead of having a note number, like being able to have 16 bits of velocity instead of 8 bits of or 7 bits of velocity. Like those are all things that are part of the UMP standard, which does require new drivers and new operating system support, as well as devices to understand that, because the actual wire format that goes across is completely different.
So when I'm using the key stage to get the parameters across, that's using CI over MIDI 1.0.
Yes, I believe it is. Don't quote me on that because I don't have a key stage here to test that out. But that could be using CI over MIDI 1.0. It could also be using CI over MIDI 2.0 UMP, because either will work. It's backwards compatible in that way.
Yeah, so that gives you that backwards compatibility so that you can do that. So why does Microsoft need to be involved in why do they need to be drivers and things like that for Windows?
Sure. There are a couple of different reasons here. One, this is an important standard for musicians, and it only makes sense if all the operating systems support it, right? If it's only on Mac OS and not on, say, Android or Windows, then how is that standard going to really take off and be relevant for everybody? It's not going to be. Like, I know in a lot of parts of Asia, we don't see this here in the US because we tend to see different demographics of devices and stuff in the US, but in Asia, roughly 80% of the musicians are using Windows PCs. And so for them to be able to be able to use this, we need to make sure that we have the support for this in Windows. This is it's something I'll be honest, like I've had kind of a bug in the back of my head for this for a long time, where I've wanted to make changes to our MIDI stack for years, because it's actually quite old. There are there are lots of files in Windows. When I look at the source files for that, the copyright has a 1990 date, like 1996, 1998 type of date on there, and hasn't been touched since then, because he didn't have to. MIDI 1.0 just really kind of worked just fine for a long time. But we've had a lot of requests for being able to have multiple applications use the same MIDI port in Windows, which we didn't support without a custom third-party driver. And we've had requests for being able to schedule messages so that you can have better kind of jitter reduction by being able to schedule the messages as they get sent in advance. And really a whole litany of things that folks have asked for that just nobody was at the time willing to crack open that really old code and kind of look at. Because you know what happens when you crack open old code, you break things, and then you end up with a lot of support issues later on. What MIDI 2.0 though did is it enabled us to say, take a step back and say, hey, we have these companies in Japan that are interested in doing some co-development with us and actually creating this MIDI 2.0 driver for us, because there's actually the companies in the Japanese version of the MIDI Association that have been writing our driver, which is open source and part of our repo. Anybody can see that. And this is a great opportunity for us to deal with all these other concerns that people have had, because this has to be net new code anyway, because the transport's completely different, the data format's completely different. Let's take this on the ground up and kind of do it the right way, in a modern way now. And so that was why we wanted to go and kind of revamp the MIDI stack. Now you might ask, like, well, why is Microsoft involved in the MIDI Association in general? Like, why do we need to be part of this? Well, we're actually part of lots of standards bodies, so that's not really unusual for us. But in this case, my real interest was to make sure that as the standards are developing, our feedback gets in there so that we know that it's also going to work on Windows. There are differences between the way Mac OS might do something and the way Linux might do something, and also versus the way Windows might do something. And that has led to, for example, the if you look at RTP MIDI, like to use RTP MIDI today, which is network-based MIDI, you have to get somebody else's driver, and it also installs Bonjour, which is an Apple product that does MDNS type stuff there as well. And that always felt like, I think it's great that Apple had that and made that so that it can be installed on Windows, but it always felt a little weird to say, hey, if you want to use network MIDI on Windows, you need to go download this Apple product and install it on here. So that was always a strange thing. And so being able to make sure that through prototyping and whatnot with the MIDI Association, that whatever standards we develop will work equally well across all the operating systems has been super important. So, for example, Network MIDI is a spec that's almost done for Network MIDI 2.0. And we've made sure that, hey, everything in there works with our MDNS stack, and we can do all the stuff we need to do over UDP. I had prototypes of it, not at this past NAMM, but the previous NAMM show, showing the communication between the different PCs, and the PC, and I think it was a Mac at the time, or actually, no, not a Mac. It was an Android device at the time. To show that Network MIDI can work here equally well across all of these. And that was a really important reason for us to be involved in it.
Yeah. So this means that the MIDI 2.0 stack is baked into Windows, or as a component of Windows, and you've not got to pull down third-party components, which makes it great for when you're trying to roll it out, doesn't it? As an end user, you've not got to try and source all these different files. Does this mean we'll see kind of the end of the proprietary MIDI drivers from the manufacturers?
So I really hope so. Once we ship this in box, like the main reason that manufacturers have their own drivers today is to work around those limitations I was talking about, primarily the multi-client limitation in Windows, being able to have two applications talking to the same MIDI device at the same time. Other than that, there's very little reason I know that there's some synchronization between audio and MIDI that some companies want to do, but there's very little reason for them to have to create their own driver. That said, if they do want to create their own driver, that's part of the reason I insisted this be open source. They can take our source that we've looked at and either contribute back to it if there's something else that needs to be in there, or they can, take that, fork it, create their own version, and ship their own driver with it. But in general, what we've asked is for manufacturers to really strongly consider if they need a driver. So another thing that enabled that is when we rewrote the MIDI stack here in Windows, we now have a Windows service in between. It used to be, here's the application, it talks to the API, and the API, through a whole set of very confusing pointer redirections, talks to these different drivers, right? It's actually really hard to trace and debug that code, which was why I'm happy to see it kind of go away. Now we have a Windows service in the middle, and that Windows service hosts plugins for different transports. So, for example, and these plugins are just COM code that are running up there. Good old fashioned COM, still kicking, alive and kicking. We have a transport for virtual, / app to app MIDI, right? So I've written a transport there that enables applications to talk to each other and to be able to send messages back and forth. Yeah. So that's a big part of it. There's also a simple loopback MIDI one, which doesn't have the additional MIDI 2.0 stuff that being a virtual device kind of entails. There is the kernel streaming one, which lets you talk to our new driver as well as all the existing MIDI 1.0 drivers that are on Windows if they're still in use. We're working on the network MIDI one there, etc. The only one of those right now that requires a driver is the kernel streaming one, because it's designed to talk to these USB devices. All the other ones are implemented as COM components, user mode code that can plug into the service. And it's not super well documented for this first release, but it will once we make sure that this works well for everybody. Anybody can write one of those. So if you're prototyping a new type of transport for the MIDI Association, you don't have to write a driver. You can write this COM component using this sample that we've provided, load it up as part of the service, and then you're able to start talking to those devices that communicate over that.
Right, that's excellent. I think the proprietary drivers are always a point of issues with reliability and people struggling installing them and whatever. So I think clearing all that up is good. But I was going to ask you about the app to app. So does this mean then I've got two virtual synths or a virtual synth and a drum machine, and currently getting really weird to get everything to sync together, you end up having to open up, say, Cubase or something and plug them all in. Does this mean now that apps can talk direct to apps over MIDI?
Yes. So there are two different flavors of that, and I can actually show the simpler one here in a few minutes if you want. But there are two different flavors of that. One is a simple loopback, which enables two applications to send MIDI messages to each other. And the user can create those in advance and have those just always available. And then applications can open a connection to that. Any number of applications can send messages. Any number of applications can receive messages. The second one is a slightly more complicated one that is done only through the API, which is because of some of the things we have in MIDI 2.0. So just really quickly here, when a MIDI 2.0 device is plugged into the operating system is then supposed to go and query that device and say, hey, what is your endpoint information? Tell me, and this all happens over MIDI messages in protocol. It's like, tell me the different functions that you have and the names of those functions, and tell me which groups they exist on. Tell me the name of the endpoint as the device would like us to see that name. Tell me your unique product instance ID. Tell me your sysx IDs. Like, there are several different messages that go back as part of what's called endpoint discovery and protocol negotiation. And so if you want to be a true MIDI 2.0 device, even if you're an application, you need to be able to respond to those messages when they're coming through. So what I've done is I've created, as part of the API, you create this object that has a definition of, here are all my functions, here's my endpoint information, here are my capabilities, here are the protocols I support, etc. You package that up and you say through the API, I want to register myself as an app-to-app MIDI device. Go ahead and put me up there. And then as soon as that connection is, or as soon as that information is sent up, and that device is enumerated, once the application that is serving up that endpoint opens that connection, the connection becomes available for other applications to then connect to, right? So, and then if the application serving up that connection closes, then that connection goes away. It's like disconnecting the cable from Windows. So there's these additional semantics that go around being a device versus just having this loopback communication between the different applications. So we support both.
Right. So does this mean that the vendors like Cubase and Logic and all the doors are going to have to update their software to take advantage of this?
Yeah. So we're already working with several of them. As you know, some DAWs are more MIDI focused than others, and so we're targeting some of those up front. At the NAMM show we're in March, so it was 2 months ago. At the NAMM show in January, I showed a build of Cubase. Now it's a prototype build. They're not shipping this yet, but a prototype build of Cubase that has been compiled against our new API and is able to enumerate these devices and send messages back and forth. And I actually demonstrated it getting high resolution MIDI messages from a Roland A88, right? So they've already done some of that work, which is great. And then I also showed a version of Multitrack Studio by Bremer's Audio, which is the same thing. So those are two examples that are going in there. Now, the other thing that we are doing here, because we know not everybody is going to move on day one, and we still want to get as much traction on this as possible. For applications that have not yet updated to the new APIs and are able to use some of the app-to-app MIDI stuff and other things, if you're still using one of our older APIs, specifically the WinMM MIDI, which is what almost every application out there uses, or WinRT MIDI, which is the version we released originally a NuGet package with Windows 8, but then shipped in box with Windows 10. If you're using either of those two APIs, we're going to redirect the functions in there to the new service. Now that's a part that's not in there yet. Because it's actually quite complicated, and Gary on the audio team is working on the plumbing to make that happen. But what that means is all of your existing applications that, like once we ship this inbox, all of your existing applications will just work with the new service, and they'll automatically become multi-client, be able to talk to the new devices in a MIDI 1.0 capacity, and be able to use these endpoints that we've created.
Excellent. Yeah, so I'm looking forward to seeing how that works. I think the property exchange and the devices being aware of each other is really the interesting thing. So I suppose if you get some kind of exotic MIDI controller with a lot of capabilities that a normal key controller doesn't have, that will talk to the software synth or the DAW or whatever and expose its capabilities, and vice versa as well for the soft synths.
Yeah, and we're also looking at, this won't be in the first release that we put out later this year, the first public release, I should say. But we're also looking at what we can do to bring some of those capabilities to older devices. So being able to have, let's say like an old application or an old device that doesn't support property exchange, can we provide a profile that can map some of those things in Windows that the user supplies and says, apply this profile, so that whenever somebody does a profile request for this device or this application, you return this kind of hard-coded data that we've provided as part of our configuration, as opposed to querying the device. So we're looking at things like that to help provide additional value, because these MIDI 1.0 devices are not going away. We all have racks and racks of them and lots of synthesizers, and sometimes the value is really in these old devices from the 70s and 80s and whatnot, or the 80s in the case of MIDI. So we want to provide additional value to those. And like I said, that won't ship in the first version, but we do want to make sure that we have something like that going forward afterwards.
Yeah, that sounds interesting. It's funny actually, because that's something me and Gary have discussed in the past on the show, is the value of old synthesizers just gets up, a Jupiter 8 or something, just the values just keep going up and up. Whereas if we look at, say, a PC not really, there wasn't a PC in 82 or 83 when that came out, so you've still got to incorporate those old technology in a modern workspace because they're still in use today, whereas old PC tech isn't.
Yeah. My first MIDI computer connection was with a Commodore 128 with a Passport MIDI interface that enabled me to use I think it was I don't remember the name of the software, but it was a multi-track sequencer and stuff. And the stuff that worked back then needs to work just as well today.
Yeah. I think my first MIDI was on my ZX Spectrum, Sinclair ZX Spectrum interface on the back of that. But then I was using that with the DX100, which is up there, and I'm still using that.
Oh, right.
But the MIDI interface on the Spectrum, well, Spectrum's somewhere, but the MIDI interface is long gone, but the DX100 still gets used. So, yeah, I think that's smart, that making that backwards compatibility and enabling old devices.
When I was in high school, the music department, like, nobody was into synthesizers, but I was really into synthesizers, and the music department let me borrow the DX100, and they had a Seal expander and one of those old 8-bit Akai digital samplers that use the same little the mini floppy disk like they used in some of the typewriters and stuff at the time. Let me borrow that for like summer vacation, and I had a blast with that stuff.
Yeah,
those are fun.
Yeah. Hey, so one other thing that we haven't talked about yet that I'm kind of eager to present a little bit of information on here is some of the tools that we're thinking of shipping with Windows MIDI services. So today in Windows, like, nobody has any visibility into what's happening in MIDI because, again, we just have that direct communication between the application and the API, and then all the pointer redirection that goes out to the drivers. With a service in the middle and being multi-client and like storing things as properties and doing, we have a lot more possibilities for providing tools that enable people to control the system as well as get better visibility into what's going on, do testing, do all sorts of stuff. So if it's okay, I'm going to share my screen here for a second. So
live demos, we love live demos.
Yeah, you got to have a demo here. So let me share this. So I have my monster screen here, but I tried to increase the font size on this to at least make it somewhat
that is
usable.
a big screen. I put it on my big screen, which looks quite small now.
I love this. It's a Dell 5K ultra widescreen curved monitor that I got, I think, like a year ago, and it's been like, if sorry, there's a little aside here. If you're a software developer, you need a really good screen, a really good keyboard, and a really good chair. Like, and anything else in the like, nothing else matters. Those are the things that you really need. Yeah. So so what I'm showing here right now is, well, let me show this first, even though I know this is somewhat smaller, but here is the MIDI settings application. This is a prototype. It is communicating with the API and whatnot. It kind of looks terrible because that's my UI design, not like a designer's UI design, but it gets the job done for now. But this is a MIDI settings application that will ship not in-box with the first version. We'll probably put it out either through the store or just continue releasing it through GitHub for a little bit here until we're sure everybody is happy with what's in there, and then we'll look at inboxing it afterwards. But this gives you a view into all the devices that you have. So, for example, I have Waldorf Iridium over here, which is running beta MIDI 2.0 firmware, and then I have a Roland A88, which is over here behind me. If you notice, they have different names than what you might expect. So if you looked here, it's called Pete's A88 because one of the things that we do is you can rename these devices now in Windows, and we store that in this portable configuration file that you can then move to another PC or something if you want to. Excellent. So it's just a bunch of JSON. In fact, do I have that open? Yeah. So like, it's just a bunch of JSON in here that the settings application writes out, and that the different or that the service will read in. And we're doing some funky things here for matching because like one of the things we run into all the time is if you take a USB device on Windows, and this actually happens on every operating system, but if you unplug it from one port and you plug it into another port, a lot of times it's seen as a new device as opposed to being seen as the same device. And that happens whenever the manufacturer doesn't provide a unique serial number for that device. It's an optional USB field called iSerial or iSerial number, one of the two. And so when you don't have that, when you unplug something, like we try to see if it's the same device, but if you go and plug in like a second one of those, then like all bets are off. We like have no idea which one is which at that point. So what we're trying to do here is provide other ways to match those devices besides just that. So even when you do remove it, from one and then plug it into another, or you move this to a new PC, which is going to get new IDs for these devices, we still try to find that device. So we're still working on that. That's what this match section is. Right now, it's just use the hard-coded device, but we're looking at a bunch of other properties that we might include in there to make it so that that's reasonable for somebody to have a home studio set up and then have like a setup that they take with them to go to perform, and like everything will still go through. And the reason that we're having to do that is because we're enabling you to have all these additional properties that are associated with these devices. So for example, I can rename the device I mentioned. We provide a description. You can provide an image so that we can use that in different stuff. I talked about having the kind of hard-coded, not really hard-coded, but user configurable profiles and stuff that come through. Then we have, all the information that just gets stored with the device that we discover through this profiles and property exchange, or through the protocol negotiation and endpoint discovery, et cetera, et cetera. So there's a bunch. I'm conveying this just for two reasons. One is so people know that these settings will be portable between machines as much as possible. So you can have these setups, and you can actually have more than one setup, so that you might have here's my home studio setup that has these 16 devices, and here's my performing setup that's got these 2 devices, and here are the properties for each. And in one case, I might name this synth my bass synth, so I don't get that confused with my lead synth or something like that. Anyway, sorry to ramble on that, but it's something. Like that. It's something that's an important part of all this, I think. So these are all the devices in the system. I see we've got, for example, here are the loopback devices. They just show up as normal MIDI devices, and those were configured through they will be through the settings application, but I've actually got them in the configuration file here, where you can see these are the loopbacks, right? So just configuring them in here. And again, we don't expect musicians to be hand coding a bunch of JSON stuff. We'll write this from the settings application, but you can see it's just text, and you can always look at that and be able to modify that as you want. And those are the loopback files there. And it's not just like the settings application is reading the JSON and every application has to read it. We actually fold it in when we enumerate the devices from the services. Like in the Windows service, when we get all the kernel streaming devices, we also at the same time look to see if there's updated configuration for that in this configuration file. And if so, we apply that information. So name and description and whatnot. And that same information is available through this is the MIDI console, which is something that has gotten a ton of use by everybody during development here. I can say like MIDI num endpoints, and I'll see the same list of devices and stuff in there, and I'll see the same names in that. And I can also use this. Let me see. Do I have another window open here? Yeah. So I have a couple of windows that are open for receiving. Like these are monitors, so I can see. Like this is from the Iridium. I can see messages coming through there, and and there's from the A88, the messages coming through from there. And I can use this to monitor the data coming in from any port or any endpoint and see what's going on in there. And then I can also do things like, so this is, go to the Iridium here. I can send messages to it. So I can say MIDI endpoint, send message. And I happen to know what a standard MIDI 1.0 protocol over UMP message might look like. So I say 1, 2, 3, 4, 5, 6, 7, and I can send 20 of those. And it's going to prompt me, and I'm going to send them to the Iridium. And my apologies if this ends up making noise. Right, and so those go to the Iridium, and I can use that for testing. I can also send them to different loopbacks and all that kind of stuff. Both the console tool and the settings application can also be used to send files of data. So if you want to do like a sysx transfer or something like
yeah,
that,
okay.
and send it right through there. If you want to be able to, also in the case of the console application here, I can actually receive a file of data and store that as a MIDI 2.0 messages. There's actually a whole lot in here. I'm trying to think. I could check the status of the service, so I can say MIDI service status, right, and it tells me it's running. I can ping the service. And it tells me like the ping time from that service for those types of things, and how many microseconds it's taking to transfer messages back and forth on that and whatnot. So there's actually really a lot in here that enables you to get health information about the service, but also, like actual usable things for more technical people. So one of the things I had in mind with this is if you are somebody who likes to script a setup for your devices and you have to send, say, a program change message at the part of something, you can write a batch file or a command file or a PowerShell script or something that can send program changes and whatever else you need, and you can run that and it'll really quickly just send those messages to that device, and then you're all set up for whatever performance setup you need to do.
Yeah, so then you could combine them so you can have a complete performance, all your devices all configured
Yep.
in one batch file.
Yep. And then the other thing we do is you can see what applications are using different MIDI devices, because there may be cases where you're like, well, what application has this MIDI device open and what's it doing? And so this is the active sessions. And each application, when it wants to open MIDI devices, registers this session with us. And at that time, we figure out, all right, what's the process ID and what's the name of that application? And then what's the session name that they've provided? And that session name, if you think about the browser, you might have a different session name for each tab in the browser. If you think about, I'm a Studio One user, and you can have different songs and stuff in your projects there. Each one of those might have its own session, and each can have its own session name there. And then I'll be able to see which one of these or like which endpoints it has open. And we'll provide some more info here with obviously the name and stuff. Right now, it's just the ID.
Yeah, that's great. So you can actually see what's happening, because that's quite, when you're troubleshooting, I'm often, trying to find why is this not working, and you're swapping cables around, and this will really assist that.
Yeah, and then finally, I think here, let me zoom in a little bit on this. So I talked about the transports being the like the COM plugins. So right now I'm working on a re-implementation of our Bluetooth MIDI 1.0 stack, which has some bugs in the original version. And since everything that I'm doing here is open source, I want to make sure that we can do the new Bluetooth stack as fully open source, which means, we have to do it from scratch anyway. So that's one of the transports that's in there. The diagnostic endpoints, I didn't talk about those, but if you're a developer and you don't have a single MIDI 2.0 device out there, we provide a built-in loopback and a built-in ping that you can just immediately use the moment this is installed without any configuration, and you can send and receive messages. Kernel streaming, the configurable loopback MIDI, the in-development network MIDI, virtual MIDI, and then we're also working on this idea of virtual patch bay stuff to make it possible for you to kind of route any device to any other device, so that if you have a keyboard and a sound module and you don't want a DAW in between, you can say, well, just connect these two, and then be able to have that happen automatically.
That's exactly what I want, because I've got the key stage, which is USB to the PC, but I've got a TX7 over there that's MIDI'd to the PC via a separate interface. And now to control the two, I have to fire up Cubase to link to be the connection to that.
There's like too much ceremony between getting inspired to make music and actually making that music. That's why you have a lot of the kind of the DAW-less jam movement, which is, let's just get the computer out of here completely and make it so that we don't have to deal with all that stuff. And we're trying to make it easier. So yeah, you could still go that route if you want to, but we want to make sure the computer is not in the way, that it's actually, helping you make music, as opposed to giving you additional tasks that you need to do before you're able to do that.
Yeah, I love the idea of that. Say just using a batch file or whatever to configure the routing so for today, I want the key stage to control the TX7 and my mod wave to control the Selena, and that's that'll do for this session. I'm not recording, I'm just jamming and want to
Yep.
improvising, whatever. Saves you having to fire up Cubase, and by the time you've done all that and set all your MIDIs up, you forgot why you were going to do it. So yeah, I really like that idea.
And we're also, this won't be in the first version either, but we're also investigating other things. Like if you're on a recent build of Windows, you'll see there are these little Copilot helpers and stuff that enable you to do stuff. Well, wouldn't it be cool if you could just say, go in there and type a prompt to connect device A to device B, and just have that happen behind the scenes, right? Without you having to know syntax for things and stuff.
Yeah, that's good. Yeah, connect key stage up to TX7.
Yeah.
Yeah.
Like there's no reason why we shouldn't be able to do something like that.
Yeah. Now you mentioned this is open source, so
yep.
There's a GitHub page and all that with all this on there. Is that designed for DAW developers, software developers to utilize that within their setups, or is this the plumbing that they would need to do their own stuff later?
Right. So the entire new MIDI stack from the driver all the way through to the API and these applications is open source. And the reason why I wanted us to do it that way is it's more about giving people visibility into what we're doing over time. And everybody knows how hard it is to debug something when you can't just go look at the code. Like if you do see a problem or you're using an API in a certain way and it's not doing what you're thinking it should be doing, being able to look at the code for that is a really important part of that process. Also being able to contribute back bug fixes, help find problems, like all the types of things that open source projects benefit from. I want to make sure that we could benefit from all those. And then somewhat cynically, I'll throw this out here anyway. Microsoft tends to change its mind about priorities from time to time. Having this live as an open source project means that it's always available for people no matter what Microsoft's decisions are 5 years from now or 10 years from now or whatever. So having that open source there, like the stuff that developers actually need to use, I put out as releases where, so it's going to be Developer Preview 5 coming out later this week, before MVP Summit to get that out there. And all they need for that today is there's a NuGet package that they reference, and then there's an installer that they run with that. When this is in box, it's just part of the SDK. And so you'll get windows.devices.midi 2 in there alongside all the other SDK stuff, and you won't need to install anything separate. It'll just be in box.
Yeah, and so when you say in box, so does that mean some future version of Windows, this will all be built in?
Yeah, so the current plan is later this year, and the date is largely dependent upon when we can get the backwards compatibility for the existing APIs plumbed in. That's kind of the long tail of stuff. While Gary and his team are working on that, I just keep adding features to the API and service, and at some point they're going to tell me I need to stop. But that's kind of the long tail for that before we put it into Windows. The driver just became awfully close to code complete, which is the other thing that we needed. It's got a couple little items that need to be dealt with, and then it goes through hardware compatibility testing, and then that can be shipped in box. And our plan is to support the currently supported version of Windows 10, which is the last version of Windows 10 that is shipped. I forget the 22H2 or something. I forget the exact version number for that. And then the current in-market supported versions of Windows 11. So it'll ship in the box with those different versions. The open source stuff, again, part of the other reason we did it up front is so that people implementing on other operating systems could see how we did it. I know before the repo was even public, I had some of the Linux ALSA folks added to it so that they could see what they're like what Windows is doing, so they can do similar things or not do similar things as appropriate for Linux, and also so other MIDI association members could see what we were doing before the repo became public.
Yeah, excellent. So really, as an end user, you just need to wait. It'll turn up in Windows, and then the application developers can start supporting it.
Yeah, if you're an application developer today, like you should go and install our latest preview of this, which will be, like I said, Dev Preview 5, because you can do all your coding against that, like Steinberg and some others have been doing. If you're an end user, yes, just wait till we ship it in box. We are hoping to get it into like the full stack and the driver and everything here into one of the Canary Insider builds much sooner than we're going to get everything into the release. So look for it in a Windows Insider build later this year.
Yeah, excellent. And we that's something interesting. I'm definitely looking to test. So that's part of the reason why I got the key stage, is just to I can do some testing that. Well, I think this is a revolution for Windows in terms of MIDI support, isn't it? I mean, it's just probably the biggest, like you said earlier, the biggest change in MIDI on Windows since it was first implemented, and the biggest MIDI change for MIDI in general.
Yeah, it's if it's kind of funny. I've wanted to see us update this for a very long time, because I'm not only the hair club president, I'm also a client, as the old ad used to go. I'm not only a Windows MIDI user, a developer, but also a user on this. And there are just features that I've wanted us to have in Windows for a long time, and being able to finally put those in place here. And thanks to my management for giving the room for us to be able to create these features and kind of serve the musician community better, and also selfishly make life better for myself as a user of MIDI on Windows. Thanks to them for that. Like, that's really what this is about.
Yeah, it's great. So what I'll do, along with the show notes, I'll include a link to the GitHub page.
Yep.
And any other notes that go with that as well. And yeah, so if someone's got questions, if you're a developer and you're wanting to do this, where's the best place to go for support and get into
Sure. The easiest place to start will be if you go to aka.ms/MIDI, and that'll bring you to our docs page, which is currently hosted on GitHub, but it'll eventually be on Microsoft Learn once we get Inbox. And that'll link you to not only the repo, but also our Discord server. And the Discord server there has had a ton of activity. That's where we've been co-developing the API and stuff here with the developers on Discord, and they've had, hey, what about this? Hey, I'm actually using Delphi and not C++, and so this works better than that. I'm a C# developer using it, and this works better than this other thing. So having like all of that feedback from those developers, as well as some more advanced users on there, has been super helpful to us. So yeah, definitely join the Discord, if anything, just to keep up with what we're doing on this space.
Yeah, excellent. Well, I really appreciate you joining us, Dan. I should also mention as well, I read a couple of your guides on building PCs or Windows PCs for musicians. I'll try and remember to include a link in that, because I found that really useful as well, like tips and tricks to get the most, when you're using Windows, to get the optimal setup. That was really helpful.
Thank you. Yeah, there are a lot of those guides on the internet, and most of them are surfacing information that was valid for Windows XP, right? But is not valid anymore. And so I tried to put something out there saying like, hey, here are like the 3 things you really need to do. And everything else is like, well, it's sort of like overclocking your PC. Yes, if you want that last 15%, you can do all these other steps, and you're going to eke every last bit of performance. That's great. If you just want to sit down and make music, do these 3 things and then be done with it, right?
Yeah.
So
I found those really handy. Well,
thank you.
Pete, it was really great getting you on the show. Really appreciate you joining us. And I think once we go perhaps Inbox later this year, perhaps we'll maybe get you back on to talk about it some more. And I should ask you as well, if have you got a favorite synth that you use there?
Oh, geez. I have a lot of favorite synths. That's my problem. My wife gets tired of seeing new boxes show up at the house.
Yes, well, I do know that. Gary knows that. I have that issue as well.
So it kind of depends on my mood. I will say that there's a lot of stuff from, and this is company much closer to you than me, I have a number of Analog Solutions synthesizers here, which they just sound absolutely massive, and they're fantastic, and they have great form factors. I don't have their gigantic wall synth. I forget what they called it, but it takes up like Colossus. Thank you.
I saw that last year at the Synthfest
Oh, it's a gorgeous synthesizer. It's absolutely beautiful. I don't have that, but I do like a lot of their other stuff. And there's also, I have an MFB Dominion, which I don't think those are made anymore now, which is unusual, and it gets sounds out of that I don't get out of any other synthesizer I have there. And then I've got all the staples. I've got a modern Mini Moog and a bunch of other stuff which just sound fantastic for kind of the bread and butter sounds as well. So I don't know. I like them all. That's my problem.
Yeah, that's that. I do know that problem. That's why I've got lots of racking in there. Well, excellent. Really enjoyed talking to you, Pete. I really appreciate that. And yes, we'll get you back on in the future, and we'll talk MIDI 2.0 some more.
Fantastic. Thank you for having me on.
That was fantastic. Really enjoyed that. I knew I would.
Yep.
And I hope that it's explained things for a lot of people about
so
MIDI
much in there. I mean, I said I'd sit back and geek out. I really did. I mean, there's just so. I mean, the traffic monitoring. Let's love that.
Yeah, absolutely. Yeah.
It's good.
So we're going to skip the news tonight because this is our special show. We will be back next week. We're going to talk about Android on Windows and new builds and so on. But we'll be back same time, same place next week. So Gary, I'll see you next week.
Take care.